In this video, I will talk about some calculations of titration, which is page 68 of your notes. Okay, all of the calculations on titration will based on these steps. You have to write down the chemical equation, which is very important, which gives you the mole ratio between the reactants, and then write down the numerical data of each substance under the substance in the chemical equation, and then find out the number of mole of one of the reactants, and then from the mole ratio find out another one, and then calculate the required information, for example mass and other things. And then the type 1 calculation, which is the easiest, we will try to find out the molarity. So example 1. So you may read the question by yourself first. Using methyl orange, because sodium carbonate, we consider it as a weak alkali, and then weak alkali react with a strong acid, then it will change color. We should choose an indicator which change color in slightly acidic condition, which is around 4 to 5. So methyl orange is the only one suitable indicator, but not phenolphthalein. And then strong acid is added from a burette, and then here is the numerical data. So for titration 1, the initial reading is 0.3, and then final burette reading is 26.9. So how much acid is added? We can look at this. In the beginning, there are a lot of sulfuric acid, so the burette is quite full, and the volume is 0.3. 0 is above, but which is empty, and then the volume is 0.3. And then we open the burette and then allow the solution to go down to be added to the conical flask, and the solution drops to 26.9. So how much is added? We should use the final reading minus the initial, because it starts at 0.3, not 0, so we didn't add that much. We subtract 0.3 from 26.9. That means we just used 26.60. And then also we calculate, we apply the same method to calculate that for titration 2, which will be 25.70. And then you check the volume reading. Can you see that this one is 26 point something, and then the other two are just 25 point something. These two are consistent with each other, they are very close to each other, but this one is very far away from them. Then we suspect that this one is not accurate. Usually, just usually, the first one will not be used, because the first time when we do it, it may not be that accurate. But just usually, if it appears as the final one, for example, the final one we get 26 something, but the first two we get 25 something, then we will take these two data and then ignore the last one. But now the one which is different appears as the first time, which is 26, so we will ignore it. We will not take this into account. We will only consider these two. So we calculate the average volume of acid added. Okay, then we follow these 5 steps to solve it. First one, write chemical equation. done. And then I will write down the numerical data below the substance, below the relevant substance. For example, sodium carbonate, which volume is 25. Sodium carbonate is here, so I know that its volume is 25 cm cube, and its molarity is 0.0527 mole per dm cube. And for sulfuric acid, the volume will be 25.8, and molarity is a question mark because calculate the molarity of the given sulfuric acid. That means we need to find it, so I put a question mark here. And then according to these information given by the question, only sodium carbonate we have volume and then molarity, so we can calculate the number of mole from it. So we will calculate the number of mole of sodium carbonate, then through the mole ratio we'll find the number of mole of sulfuric acid, and then lastly the molarity. So how to calculate the number of mole? We have volume and molarity, so it should be as we know, molarity equals to number of mole divided by volume. Molarity equals to number of mole divided by volume. So when we rearrange it, number of mole will equals to molarity times volume. So here, molarity times volume. Zero point 0.0527 times 25 divided by 1000, which will be 0.001317 mole. If you don't know how to read this number, then you can just try to add 1. Then you will know that it's 0.001317. And then next we need to calculate the number of mole of sulfuric acid. And then according to the mole ratio, it's 1 to 1. When it's 1, then it will also be 1. So the number of mole should be the same. And lastly, we need to calculate the molarity of sulfuric acid. Molarity equals to number of mole divided by volume. So number of mole is, and now volume is 25.8 divided by 1000. So this is the answer, -1, which is 0.001317 divided by 25.8. So the answer is 0.0511. As you see that it's different from that, from the final answer, but it's fine. It's because this answer may be obtained by another number of mole, which I make it to a 3 significance figure, so it may be slightly different, but this one is fine. Okay, so can you do exercise 1 below on the same page?